Welcome. Now, note, this is a concluding class for two blocks connected by sometime cable, sometime a rod. That does not matter now. You know it. If cable, it will be in tension. If rod, it can be either tension or compression. Okay. Now, the concluding part, two questions are there. Remember, two important concept-based questions. The purpose is that complete concept will be clear for you regarding friction. As we go further and further, I cannot explain all these things. See, I always told, every time I was telling, go through each and every class. Then only concept will be clear. So half studying or random studying is of no use to gain knowledge from my class. Okay. Now question 32. See, once again I am taking same two blocks, 6 kilonewton weight, 10 kilonewton weight, mu 0.5 here, mu 0.4 here. Okay, but this time I am giving inclined force. Okay. Two blocks A and B are connected by a cable, see here cable, and placed on a rough horizontal surface with the force of 5 kilonewton applied to the block B. How much? 5 kilonewton? Oh, okay. I wrote 4 kilonewton. Okay, no problem. What is there? 5 kilonewton. Okay, 5 kilonewton applied to block B. Means some 5 kilonewton load is applied here. As shown in figure. See, 1 minute. Ink problem. 5 kilonewton. Okay. With the force of 5 kilonewton applied to block B as shown. Means inclined force at an angle of 40 degrees. If I give horizontal force, when you go to solution, it becomes easy for you. Okay. Then, see, they are telling weight of block A is 6 kilonewton, weight of block B is 10 kilonewton. Coefficient of friction is 0.5 here, 0.4 here. It can be given by words also. How words? Weight of block A and weight of block B are respectively 6 and 10 kilonewton, and friction coefficient for contact surface of A and B with that horizontal plane is 0.5 and 0.4 respectively. Okay, this is all usual statement. Now, see the question. Again, I put a little more ink actually. That's why ink is spreading. Okay, 5 kilonewton. Okay. Now, what they want? Check whether the system of blocks will move to right or not. Means you should write here. When you apply that 5 kilonewton force, will it result in motion of the system, complete system to right? Question is, will it move or not? See? So therefore, will it move to right or not means we do not know. It may move or it may not move. We will be knowing later. Then, second, see, this is one part. Second part is, see, answer can be what? Check whether the system of block will move to right or not. Answer can be either no or yes. We don't know. So I am first giving if no. No means will not move to right. So if no, see for this question, whether the system of blocks will move to right or not when you apply this force, if the answer is no, then find what least force is required to start the motion. What least force required means understood. Instead of 5, how much is the least force required to start the motion? What is the least, on share? What is the least, I'll put here now, additional force. Okay, that is much better to understand. Least additional force. Additional force is required to start the motion. That means when they asked you to check whether the system will move or not, in case your answer is no, it will not move, then they want to increase the force. See, natural. When 5 kilonewton is not able to move, this force is to be increased. They are asking you, additional means how much more required. Okay. Or, see, or is here. This, see, start the motion. I'll put here now so that confusion is there. Okay, motion. That ink problem is actually, I have put more ink than required. Okay, motion. Now, see, or means Or if yes, suppose this force results in the motion. Answer is what? See, I will not tell once again. Here question is what? Will it move or not? First you have to find that one. First you have to decide. Then, if the answer is no, surely you require more force. You have to increase this force. They are asking you how much increase required. Or if the answer is yes, means what? When you apply 5 kN mode, if the system is moving to right side, then what least horizontal force, this is inclined force, what least horizontal force is required to be applied to block A to prevent the motion. See, I will tell the question now. See, by chance if the answer is no, the system will not move, then what do you have to do? You have to increase this force. Find how additional means extra. How much increase? Suppose the required is 7 kN, answer is not 7, 8 kN, increase is 3. Right? 5 is there. How much increase additional means 3 is the answer. Okay, that is first part. Or suppose you are for the question here, if yes means if this 5 kN will move the block to right side, then I don't know why they want to prevent that motion. How? Don't apply force this way. If you apply force this way, it will further move. So if the system is moving to right side, what horizontal force is required? Horizontal force is required to be applied to block A here. See, 100% it is to left side. Why? When it is moving to right side, to prevent it, this should be to left side. It's okay. Required to be applied to block A, not B. Okay, B means B also will do. If they tell for B, then you are right this way force. See, then to prevent the motion, you should take P this way, pushing force. See, when the system is being pulled, to prevent it, you have to push it back. But here, they don't want to mix up here. See, when it is moving that side, they will tell here how much horizontal force required. Okay, now class. What you do is, you do not consider 5 kN. See, if you consider 5 kN, what is the problem? We do not know is this 5 kN will move the system or not. If it moves the system, it becomes dynamic friction. Then you cannot write what? Friction force equal to mu into RB, mu into R. Or if it does not move, then it is static friction. Again, friction will be lesser. Therefore, what you do is replace the inclined force of 5 kN. Okay, I wrote 4. I don't know why I wrote 4. Inclined force of 5 kN to block B by unknown force P. You replace it by C, unknown force P. Unknown force P for which the system of blocks is on the verge of moving to right side. They want to check whether this 5 kN will move or not. What you do? Find the least force, see, unknown force P for which the system of the blocks is on the verge of moving to right side. I will tell you how. That answer will finally come 6.8416. Now you know the answer. I will tell last, I will tell you. Okay, start. Now, free body. But main, both diagram, 6 RA. These all now onwards you have to write. Let RA be the normal reaction, RB be the normal reaction here. See, system is moving to right side, friction is to left side, and this P will make the block on the verge of moving. Therefore, limiting case, this friction force, see, when it moves right side, friction left side, 0.5 RA, this is 0.4 RB. If this is not clear, do not continue my class. Question number 32. In the beginning, so many times explained, every problem explained. Okay, now onwards for such questions, I want to waste time, consider equilibrium of block A. Why block A? Write the reason here. You write why block A, you write here. See, block A, RA and T, two unknowns. Block B, T, P and RB, three unknowns. So start from block A. 6 down, RA up, T and 0.5 RA, sigma Fy 0, RA minus 6 equal to 0. Direct answer. Now you should work out. RA will come 6 kN, sigma fx0 plus t minus 0.5 RA equal to 0. Substitute RA 6 kilonewton, T will come 3 kilonewton. Okay. Now consider equilibrium of block B. 10 down, RB up, C, and 3. Inclined force P. So, pencil mark. Use 40-degree angle with horizontal. Cos, sine. You should know it. Start. Sigma Fy0 plus P sine 40 plus RB minus 10 equal to 0. Equation number 1. Simplification, constant take that side. That all you do it. You are not a primary school or high school student. You are engineers. That much mathematical knowledge required. Someone will tell, he is not simplifying. What simplifying? Sometimes I get angry also. See, here I can't get angry. Offline class, sir, better simplify. I will tell simplify. Sorry, sir. Okay. Then sigma fx0 plus p cos 40 minus 0.4 RB minus 3 equal to 0. See, this 3 is already known there. You will solving 1 and 2, we get P equal to 6.8416 kilonewton. Now do one thing, some statement required. I will dictate, you should write it. Okay, now see, I will dictate the statement you write. The question is, first part of the question is to check whether a 5 kilonewton force applied inclined way this way will result in motion or not. Right? That is the question. Now, we just now found that the system of blocks is on the verge of moving when the P value reaches 6.8416. So, to start the motion, the least force required is 6.8416. You write here. But applied force is only 5 kilonewton. Therefore, right here, you write all these things. The system is on the verge of moving to right side when the value of P reaches how much? 6.8416 kilonewton. But actually, applied force is only 5 kilonewton, which is less than the minimum force required. Therefore, that 5 kilonewton force will not move the block, move the system of blocks to right side. That is the conclusion for the first part. Okay. Come to second part. Second part is, one is if no, other is if yes. This question, it is no. Next question, it is yes. I will set the question that way. This question, no. So, if no, something required. If yes, so if yes, right here, in this question, the if yes is not applicable. Why? They are asking you if it moves. No, it will not move. So, if no, I think I should not write on the board. If you are serious, what I dictate, you write. If no, you write here. Now, second part of the question. That is, they want to find how much force, same force, instead of 5, how much extra force is required. How much, see, if no, find what least additional force is required to start the motion. Right? So systematic. Somebody on the road will answer. Block will start moving at 6.8416. Applied force is only 5 kilonewton. Therefore, you require additional force. Therefore, right, to make the block require to what least force. Start the motion means on the verge of moving, you require additional force of 6.8416 minus 5 equal to 1.8416 kilonewton is the answer. Over. I will tell you what. Simple example. You have 100 rupees in the pocket. You want to buy something. Question is, can you buy something? If no, see how much money, more money is required. If yes, it is not applicable now. If yes, how much reverse you have to apply? How much money you should once again remove and put it in the house only. See, 100 rupees required. What you do in this question? When you found the cost P, imagine cost is 150 rupees. Oh, therefore, with 100 rupees, you cannot buy, you require extra force of 50 kilonewton, extra money of 50 rupees. Okay, now, by chance if the cost is 80 rupees, answer, yes. What? The 80 rupees, cost is 80 rupees, you have 100 rupees, yes, you can buy. Then, how much reverse means, how much money you can keep in the home only, don't take it. Remove the money, how much? 20 rupees you can remove, over. This is simple question, 32. Now go to 33. See, in this question, if no and if yes, both of them they want answer. This question, if no is applicable, if yes is not applicable. Now last question of connected bodies, where I will make yes. I will set the question and then solve to save the time. Now, the last question of two connected bodies placed on a horizontal plane. Problems here. Okay. Horizontal plane. Last question. I already told both these questions today's class are concept based. The last question is more concept based. Okay, start. See, two blocks A and B are connected by a cable and placed on a rough horizontal surface as shown with a force of 11 kilonewton applied to block B, not inclined. If I give inclined, what will happen? Resolution required. It is not a big issue. You understand the concept. So no point in wasting time because space also is not there. 11 kilonewton, see, with a force of 11 kilonewton applied to block B as shown in the figure. 6 kilonewton weight, mu 0.5, 10 kilonewton weight, 0.4, see later, 6, 10 RA, RB, 0.5 RA, RA, 0.5 RB, all known for you. Now I will not explain. Tension T. Okay, now, question is same as last time. Check whether the system of blocks will move to right or not. If no, see, now it can't come no because if it comes no, it becomes once again the previous question. But anyway, for you, you are not knowing. You take independent question. First, they are asking you whether this force of, don't see there, whether this force of 11 kilonewton will move the block to right or not. Now, suppose answer is no. Means what? 11 kilonewton is not sufficient. You require extra force. Suppose the force required is 13 kilonewton. 2 extra required that way. So find how much least additional force is required to start the motion. Or if yes means what? Is 11 kilonewton, if it moves the system to right side, then what least horizontal force is required, horizontal force, to block A to prevent the motion. To prevent the motion, remember, it is moving to right side, you want to prevent the motion, least force, okay. And one concept based, see, if it moves to right side, how to prevent it? Apply a force this way, so that it just prevents. Then, see, some force will come here, how much? Some force will come. Then, if you increase that force, what will happen? The tendency of the system will be to start moving to left side. And if you keep on increasing further, finally a stage will come when the system of the blocks will start moving to left side. Yes, see here. And also find, see here, if no means over. If no means find additional force. Question is over. But if the answer is yes, means if this 11 kilonewton moves to right side, find what least horizontal force is required to prevent the motion. One answer. Then again they want to find how much least additional force required to be applied to block A So as to start the motion to left side, here concept will come. So I'll start first, I'll solve fast. See, statement I'll give later. Once again, don't see 11. Replace 11 by a force P. Replace the 11 kN force applied to block B by unknown force P, for which the system of blocks is on the verge of moving to right side. Okay. Put the sketch. Start here. This will remain same. Here it will become very simple now. RB equal to 10, sigma fx0, no resolution, plus P minus 3 minus 0.4 RB equal to 0. Substitute RB equal to 10. 10 is 4. P will come 7 kilonewton. Okay. Now, very important. I will give the statement. 1 minute now. I will give the statement now. See, if anybody cannot solve all these, they are not fit to come to my class. These are all, see, because these all you should do it. Now, our purpose is today concept-based question. Okay, now, I will give the statement for you and continue the question. 1 minute. Now, continue the statement. See, what all I dictate, you should write. What all I dictate. The force applied to block B is 11 kilonewton to the right side. And we are asked to check whether the system will move to right or not. For that, what we have done, we removed 11 and in that place, we put an unknown force P, which will just start moving. And finally, we got the P 7 kilonewton. P equal to 7 kilonewton. So, when the force is 7 kilonewton, the block is on the verge of moving to right side. But applied force is 11 kilonewton. So, that is more than your P of 7 kilonewton. Therefore, at force of 7, see, at the force of 7 kilonewton, the system is on the verge of moving to right side. But you are applying a force of 11 kilonewton, right? Therefore, that applied 11 kilonewton force to the block B will result in motion to right side, right? That applied force of 11 kilonewton to block B will result in motion of the system to right side, right? Okay, then, now, further. If yes, this time, answer is yes. Last time question was no. How much extra force required? Now, this is more than required. So, if yes, what least horizontal force is required to be applied to block A to prevent the motion? So, right here. Now, see, this is all gone now. Now, right here, statement. Let, see, that is already P is there. No P now, let. I won't call P. P dash be least horizontal force. Horizontal force. Actually, I know the answer. It is simple. By just looking only, I can tell the answer. But we will solve systematically. Why? Because if inclined given, you have to solve. Okay. Let P dash be the least horizontal force to be applied to block B, block A, not block B, block A, to prevent the motion. To prevent the motion. Okay. Apply a force, understood. It should be to left side. See, P dash should be to left side. Now, it is not P. Now, this force is 11 kilonewton. See, that is prevent the motion. When what? When 11 kilonewton force is applied to A, applied to B, applied to block B, which is actually moving to right side. How much it is? 11 kilonewton. So this 11 will move to right side. To prevent it, you require force this way, P dash. Okay, now consider equilibrium. Our other thing is same, equilibrium. First remember now, see, if I take block A, RA, T and P dash, three unknowns. Block B, RB, T, that's all. So this time you should interchange. First consider equilibrium of block B. Very important, block B first. Weight is 10 kilonewton. Reaction RB and frictional force for B limit is how much? 0.4 RB. It is 0.4 RB. This is a sketch. See, you can, and one more thing. B. Therefore, here, see what? Here a force of 11 kilonewton, and this side tension in the cable T. See, this side tension in the cable T. Now see, you are considering this block 10 down, RB up, and FFB of 0.4 RB and T. Sigma Fy0 will give RB equal to, you solve it, RB equal to 10 kilonewton. Why? So simple. RB minus 10 equal to 0. Sigma Fx0 will give you, see, plus 11 minus 0.4 RB minus T equal to 0. Your T will come. I will calculate, not a big issue. I will calculate. See, how much? 0.4 into 10 is in equation mode 1. 0.4 into 10 is 4 kilonewton. That is 11. So it will come 8 kilonewton. 8 kilonewton. Or, see, 1 minute here. See what you write? Minus T, I should not write minus T, then minus 0.4 RB plus 11 equal to 0. Substitute RB equal to how much? 10 kilonewton. When you substitute RB equal to 10 kilonewton, T will become, see, this is, what happened? Minus T. See, I am wondering what happened. See, minus T minus 0.4 RB plus 11 equal to 0. So T will come 11 minus 0.4 into 10 is 7 kilonewton. Oh yes, 7 kilonewton. See, I don't know why 8 came. 7 kilonewton. See, unfortunately, no mistake. I don't know, while counting, it became mistake. 10 into 0.4 is how much? 4. 11 minus 4 is 10 into 0.4. 10 into 0.4 is 4. 4 means 11. Yes. 11 minus 4 is 7. By mistake, I took 8. If it is 8, someone would have commented, does not know the concept. Okay. See, now you can make out, see, minus T plus 11 minus 0.4 RB. I will check once again. 0.4 into 10 is 4. Then 11 minus 4 is 7 kilonewton. Okay. Now consider equilibrium of block A. Not block A, sorry. Oh yes, block A. Block A. When you see this way, then see, here block A, tension right side, tension of 7 kilonewton. Then a force this side of P dash, and purpose of P dash is to prevent the motion, means block is on the verge of moving to right side. See, when 11 is there, it will move to right side. So you apply a force so that it is on the verge of moving, still not moved. Okay, P dash, then RA, this is RA, and this is FF for A. Anything mistake here? RB, FFP. Okay. RA, FFA is 0.5 RA. Sometimes it happens. I forget to change the values. Okay. This is the equation. Okay, start. Sigma, make sigma Fy0 plus RA minus 10 equal to 0. Your RA will come 10 kilonewton. Then sigma Fx0. You get minus P dash here. You get minus P dash. Wow, P dash is black color. Okay. Minus P dash plus 7 minus 0.5 RA equal to 0. substitute RA equal 10. Then 0.5 into 10. How much it is? 0.5 into 10 is 5. If it is 5, correct answer, minus P dash plus minus 0.5 RA plus 7 equal to 0, correct? Okay, therefore, your P dash will come 7 minus 0.5 into 10 will give 2 kilonewton. Your P dash will come 2 kilonewton. Okay, now write the statement. I will dictate, you should write. Therefore, by chance, if any calculation mistake is there because of I am changing the numbers here, sometime what happens is one number forgot to change. Concept I am telling. Okay. Actually, it's correct only. See, 1 minute now. Anyway, I don't want mistakes here. 6. 6 into 5 is 3. Here, 10. 10 into 0.4 is 4. 4 and 11 means 7. If it is 7 here, RA is 6. 6 into 0.5 is 3. Oh, see, mistake is there. I know. It is 6 kilonewton. See, I was wondering why it is happening. Okay. See, 6 kilonewton. Luckily, that's why I check always. See, one small mistake. This is because I am doing same question repeatedly. If it is an independent question, such mistake will not come. So 6, RA will come 6 because I had doubt about 3 kilonewton. I was expecting some other answer. See, 0.5 into 6 is how much? 3. 7 minus 3 is 4. It is 4 kilonewton. I know that answer, 4. See, 11 means 4. Okay, now write the answer. Therefore, what I dictate, you write. When you apply 11 kilonewton force, the system is will not on the verge of moving. It will move to right side because it is on the verge of moving when this force is 7 kilonewton. See, already you got earlier. But applied is 11 kilonewton. So, the system will move to right side. Somebody wants to prevent it. How? By applying a force here. That is P dash. Apply a force P dash so that the moving to right side is just prevented. So, tendency is still to move right side only, very important. So, that force required is horizontally left side or a pulling force of 4 kilonewton is the answer. Okay, now concept comes, be careful. Now concept. Okay, now once again continue question. See, now continue. See, right here. There is something extra, something further. I will dictate. What further? See, first they told how much force is required to apply to this block. Your P dash came how much? P dash came 4 kilonewton. Now, something extra. 11 is already applied. Your P dash equal to 4. So, when P dash equal to 4, see, if it is less than 4, system will move to right side. It will move. When it is 4 kilonewton, it is on the verge of moving to right side. Now, increase the P dash. Slowly, the system will be still in equilibrium and that force is more. Tendency is still to move right side. Finally, as you increase the force, a time will come when suddenly the system will start moving to left side. See, if you apply a very heavy force here, system will move to left side. That force they want. How much force? See, right here, let. Now I'll do one thing, not P dash, I'll put a P double dash. B, horizontal force to be applied to block A, that P double dash B, least horizontal force. Once again, limiting case, horizontal force to be applied to block A to start motion of system to which side? See there, to to left side. Very important. System to left side. Left side. Okay. Now make a note here. You write this as P double dash. P double dash. What about 11? 11 will be there. 11 is already applied. When you apply 11, 4 will prevent it from moving to right side. If you increase to high, still higher, suddenly system will move to left side. Now, so take it. Very, 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 very important. Now, when you are finding the force P double dash so that the system is on the verge of moving to left side, not right side, left side. Therefore, very important, frictional force will reverse. See here, the frictional force will be to right side. Why? See, if the tendency is to move to right side, friction is left. Now, see what will happen? This P double dash will overcome the friction. Again, it will start moving this way. Then friction will become other side. See, when the system starts moving left side, friction is right side. Very, very important. See, you write here, important. Frictional force FF limit for both block A and block B will be to what side? Right side, because P double dash force is that force which will start the motion to left side. Okay. Now, once again, unknown. See, RA, T, P double dash, 3 unknowns. RB, 10, 11, T, 2 unknowns. First consider equilibrium of block B. See, 10 Kn, RB. Now, see, slightly I am shifting here. See, here also. I am slightly shifting here. You know the reason. RA, slight shifting because pressure comes more this side. Okay. Don't bother, RB. This is RA, B first, RB. This is RB, and then we are doing B here. Friction is to right side. See, friction is to right side. That is FFB limit 0.4 RB, and this force is 11. Okay, start. Here, tension T. Okay, start. Sigma Fy 0, RB equal to 10. Sigma Fx 0, right here. Sigma Fx 0. Right side positive. So, minus T plus 11 plus 0.4 RB equal to 0. See, minus T plus 11 plus 0.4 RB 0. Substitute RB equal to 10. You will get the value of T in kilonewton. Your T will come minus here. Okay. 11 plus 0.4 into 10. 15 kilonewton. T will come 15 kilonewton. Everything correct? We'll check once again. B first. 10 RB 11 T 0.4 RB. So RB equal to 10. Then minus T plus 11 plus 0.4. 0.4 into 10 is 4. 4 plus 11 is 15. Correct. Okay. Now consider equilibrium of block A. This force is P double dash. See, this is P double dash. This force is tension T is now 15 kilonewton. And then weight is, now A you are doing 6 kilonewton. RA, FFA is how? Right side. See here, FFA is right side because block is moving to left side. Sigma Fy0, RA will come 6 kilonewton. Sigma Fx0, see now, Sigma Fx0 will give you right side positive, you will get minus P double dash, then plus 15 plus 0.5 into RA equal to 0. Substitute RA equal to 6 kilonewton. Therefore, your P double dash will come P double dash will come in kilonewton. How much? 0.4 into 6 or 0.5 into 6, then plus 15 is 16. 0.5 into 6 is 3. 3 plus 15 is 18 kilonewton. It is everything correct. I'll check once again. 18 kilonewton. To move the block to left side, you require 18. Correct. I can make out 18. Why? 7 required. See, if this 11 is not there, 7 required. Now 7 required, it has to overcome 11. Okay. Don't worry, you solve the question. Now, lastly, I'll give statement. Therefore, I will dictate to make the system to move to left side, the horizontal force to be applied is, that is P double dash is 18 kilonewton. But remember, this is not the answer. The question is what they asked you. They asked you first what they asked. What force is required here to prevent the motion? What is that answer we got? I forgot that answer. What force is required here to prevent the motion? I forgot that answer. 1 minute. I should have noted that answer. Okay, 1 minute, I'll check it. I'll check that one. Now I can't clear that. Pause. Okay. Actually, I unnecessarily paused. My mind was working somewhere else. Reason I won't tell. Okay, that's why actually, why I don't know why I paused it. Checking not required. It is 11 minus 7. 4 kilonewton. I can look by looking and tell. I told earlier only 4. Sometimes what happens is, see, when you do so many questions, number gets missing. Suddenly, if I think a little, I don't have to go to recording and check once again. Then suddenly I realized, oh yes, why me checking not required. Okay. Now see, last statement, the system is on the verge of moving to left side when the force P double dash reaches 18 kilonewton. Now, suppose the question is, what force is required to move the system to left side? I am dictating. Suppose the question is, what force is required to move the system to left side? Answer is 18 kilonewton. But question is, first they want what? How much force is required to prevent the motion? See, to prevent the motion, you required 4 kilonewton. You already got the answer. Right here. To prevent the motion to right side, we need 4 kilonewton. And when that 4 becomes 18 kilonewton, system is on the verge of moving to left side. Therefore, additional, they want additional, correct? See, they want additional, see here, additional force, horizontal force, understood? Additional horizontal force to be applied to block A to move the system to left side is, see, 4 is already applied, but you require 18 equal to 18 minus 4 equal to 14 kilonewton is the answer. Additional, see, required force is how much? 18 kilonewton, but 4 is already applied to prevent the motion to right side. So further you have to apply another 14 kilonewton. Okay. Concept should be clear. This question will make the concept fully clear for you. Okay, now over. With this I am closing questions for 2 connected blocks in horizontal plane. Unless I find later that some important question is there. In case later, if I suddenly found out some important question is there, I will solve as additional question. Okay, now we will go to inclined planes. Not now, next class. Okay. Thank you. Next class we will meet.